Hello and welcome to this webinar, to the replay. I will start with an introductory video to illustrate what we are going to talk about today, namely the essential biodiversity variables and metadata. And welcome back. Now what you saw was the diversity of biodiversity here in Europe. I was traveling first to the Arctic and then to the island of Madeira in Portugal, and I was doing that during a span of 10 days only. So you see there's a big difference in the climate that we have here in Europe. So welcome to this webinar. I'm Bente Lilja. I'm going to be your host today. And with me, I have a whole panel of speakers. And we will talk about metadata, of course. We will learn a lot about biodiversity. I'm sure if you're new to biodiversity, you will learn something very interesting here today. You will get a demo of what we've been working on in the Next Geos project. You will be, of course, introduced to the INSPIRE Hackathons. This webinar is a part of a series of webinars that we are organizing in the INSPIRE Hackathon. It's a Orléans OGC Hackathon. And the reason why we call it the Orléans OGC INSPIRE Hackathon is, of course, that OGC is one of the key co-organizers. And with us today, we have Marie-Francoise Voidrot, who will tell you a little bit about why this particular hackathon is important for OGC, which is working on standards. And we will also get the latest on what we are doing in with our Next Geos data hub for Europe, and particularly a focus on metadata. And we will also look at this, a subset. There's, as you know, biodiversity is like planet is very complicated. So, but we are focusing on a subset of these biodiversity variables, and you will learn about that as well. So before I go ahead and introduce, yes, and here we have also Karel Charvat from Plan for All, Data Bio, from Next Geos, and a whole bunch of other organizations. But we haven't done the tour de table yet, so I will start this webinar now with introducing the speakers to you. So I think we can go. Well, we can start with you, Karel, since you made it in here.
Okay, so my name is Karel Charvat. As Bente mentioned, I am working for Plan for All, but I am also involved in a number of the project, and I think that I am one from the parents of this INSPIRE Hackathon initiative. We start with this, and we try to move and do the best to join community and support open data and other initiatives.
Yes, Karel, indeed. And well, Stephan, let us hear about you.
Yeah, okay. I had to switch on my microphone. So my name is Stephan Hennekens. I work in Wageningen, Netherlands, in Environmental Research Institute. I'm a vegetation scientist and also an enthusiastic software developer. I'm responsible, among other things, of the European Vegetation Archive called EVA, and also SPLOT is also a vegetation database with a global scope. So I think that's enough for the moment.
Yes, and we are looking forward to learn about the pilot that you are working on for biodiversity. And Wolfgang, you are going to help connect this pilot to the CKAN-based European Data Hub. Can you introduce yourself as well?
Yes, thank you. My name is Wolfgang Ksoll. I'm project manager here at Voidrot. Voidrot is a daughter company of the Open Knowledge International, and we are building data hubs with the open source software CKAN. We will see it in a few seconds. In former times, I was born as a miner, coal miner, so I have a license to solve problems with a sledgehammer.
Good to know. And Marie-Francoise from OGC, can you tell us a little bit about yourself as well? Marie-Francoise, I think I'm afraid we have to turn off your camera again because your voice is breaking up. Yes, this is better. Go ahead.
I'm working with the Open Geospatial Consortium, which is a not-for-profit organization defining standards and working on interoperability of standards between various domains.
Thank you. We are looking forward to hear more about OGC and your work later. And finally, but not the last and least, Elnaz.
Hello, I'm Elnaz. I'm a researcher fellow at ITC University of Twente, the Netherlands. I'm involved in NextGeo projects, biodiversity pilots, and particularly for data hub for creating data hub for essential biodiversity variables. My expertise is remote sensing, particularly over thermal infrared domain. So that's it. Yeah,
we are looking forward to hear more about how you are attacking the biodiversity seen from space, the variables seen from space.
Yeah, sure.
So before we start, I will just do some more housekeeping. We are having all these presentations today, but in between, we are happy to get your questions. If you have any questions or comments that you want to share with us, please write in the chat box, and we will try to answer them in between the presentations and or towards the end of the webinar. And please do not hesitate to share this webinar. Even though we have just started, people might be finding it interesting to join in order to be able to ask questions directly. And as you know, you will get this this webinar, the replay of this webinar will be sent to your inbox directly. Yes, so I think we start with now something happened here. It seems that I lost all the windows. Can you hear me?
Yes.
Yes.
We can hear you.
Okay, good. So I will give the floor to you. Oh, here we are back. I will give the floor to you, Karel, so you can introduce the audience to the framework of this webinar, namely the Orléans OGC INSPIRE Hackathons, and we will learn. You will tell us more about how the INSPIRE Hackathons was born, so to speak.
Okay. No.
You need. Okay, here he comes.
Not correct. Sorry.
Did you?
Just a moment.
Yeah.
I have to do this again.
So.
Okay. Do you see my screen?
It's coming now. Yes, we see it,
Yes.
Karel. Go ahead.
Okay, so as I will repeat partly what I already told, that INSPIRE Hackathon is not the event, it is the process. Yes, we start in Barcelona. It was in 2016, and it was the first INSPIRE Hackathon. And from this time we grow, and we made not only hackathon on the INSPIRE event, but also number of satellite hackathon as the process. And the goal is to support open data policy. And what is very important, that our hackathons are more focused on the expert. Yes, what I saw in the past, that very often there is low sustainability of the project results. There is no cooperation with different projects. So we start to build this hackathon as some playground for the expert from different project companies to work together. And we are trying to do this in Europe, but also we already start cooperate in our hackathon with the people outside of Europe. And we are focusing on data integration, but also on the tools which support the management of the data. INSPIRE is on the base, so INSPIRE we use as the platform, but we are organizing a number of hackathon. From last INSPIRE, which was in Kel, we already organized hackathons in Pilsner, Prague, and now will be Orléans hackathon. And Orléans hackathon, we decided to be not very broad in our scope, but to go in the really focus, and we decided to focus on the metadata. It is from more reason. One thing is that okay, last time I mentioned that metadata probably are boring for many people, but are important. This is one thing. Other things is that metadata are important for discovery, and also in OGC is now prepare new best practice document. It is about Geodica document, and we see this as the good chance to put together some could be work of standardization together with some practical tests. The main target, or not only, is on the Geodica IP. We will be able to focus on satellite data from Earth observation, but also on connection of the metadata and link open data. For participant, it is necessary to register on this URL. I think that Bente, because I'm using presentation from last, you have already this presentation, and we have also our collaborative space where you can edit your ideas or connected existing teams. All information are on the portal www.planforall.eu, and you can find there all information, and you can also find there any news and any new idea about Orléans hackathon. I think that it was shortly from my side. I think that more interesting will be the presentation of my colleagues about the ideas and how we or what we plan to do.
Yes, thank you so much, Karel. It's nice to have sort of a background for what we are doing here. And before we dive into the biodiversity and the metadata further, I think that Marie-Francoise can give us an additional motivation, or tell us more about the motivation for OGC to be engaged in these topics. And Marie-Francoise, are you ready to talk about the presentations? I have them here ready to share the slides. If you are ready.
I'm ready.
Okay. So I will share with you.
So The Orléans Hackathon will happen during a technical committee of the Open Geospatial Consortium, and the presentations and awards will happen on the 22nd of March, Thursday, in Orléans. And I will introduce you a little bit. Next slide. What is OGC and why we are hosting this hackathon? So OGC, the Open Geospatial Consortium, provides a global forum for the collaboration of geospatial data or solution providers and users to advance the development and use of international standards and supporting services that promote geospatial interoperability. Next slide. It is a not-for-profit organization which was founded in 1994 and gathers more than 520 members. And one originality of this standard organization body is that we host and we organize a lot of innovation initiatives, which is type of hands-on processes to test which are the issues we still have to work on to advance the standards and improve the interoperability. So we have released already several standards, but as I will tell you later, we have other types of document and standards. So the Open Geospatial Consortium organizes the works through 4 programs. One is the innovation program. It is the one I am attached to. And this is where we organize and coordinate these innovation activities. It's type of research laboratory and of OGC to test what we have to improve. It's a rapid prototyping and testing activities to look for the issues we have to push forward. Then we also have a standard program, and what the issues we identify are sent and documented to the standard program so that they can improve and push the standards further. Next slide. So metadata, the works are organized in suites who define the standard working group, who really work on the standards, and the domain working group, where we work around domains like aeronautics, meteorology. I was chair for the Met-Ocean domain working group for several years before. And metadata is one of these domain working groups. Next slides. So what we can observe is that there are several metadata standards already existing. The main one and the reference is the ISO 19115. And there are other ISO standards around that can help to define metadata and uncertainty around the metadata. And INSPIRE has made a lot of works around metadata. But there are also metadata which are different, which are defined from the open data community and the e-government, which is the DCAT. And out of DCAT, there are several flavors of DCAT for geospatial data, for instance, the GeoDCAT, or for statistical data, the StatDCAT, and so on. And then you also have some other type of metadata standards for the archive world, like the Dublin Core. Next slide. So this is why when you want to, you can go to next slide, Bente.
I am.
Okay. This is why when you want to make data discoverable to all communities from all type of data sources, because this is where we are now, we need to get advantage of data coming from different communities to push the innovation and make possible to develop new products. And so we want to improve the discovery, and this is why we have to test. I don't have the next slide myself, but okay. And this is why we are working now on best practices to work on the alignment of these different standards and try to see how they can match and how we can discover further and align the understanding of all the community so that we can work further. Next slide.
advancing innovation.
Okay. It doesn't appear on my screen, so it's a little bit confusing to me. But so the challenge here is that each community can have its own implementation of the metadata and its own profile. For instance, biodiversity will need a lot of good metadata for provenance and uncertainty. And they also have works which are going on control vocabularies or thesaurus. And this is where we have to understand where are the limits and how we can support the works to improve the interoperability. And this is why we are interested in implementing this hackathon and try to align understanding and identify and share the understanding of the current issues.
Yes, now there's the last one is the agile prototype, but I think you rounded it up there, Marie.
Yeah, I don't have the slide, but these are the different types of experiments OGC implements, depending on the size of the experiment, depending on the maturity of what we want to push further. We have different types of initiatives, which can be the plug fest, which are the biggest one, and the hackathons are one of them. And this graph explains that the hackathons, pilots, and so on are the different types of initiative we implement to improve works. Thank you.
Mm-hmm. Bente, I also didn't see the last slides. I don't know what's going on, but
me neither.
Okay. Bente, are you there?
Slides away, Bente away. But she will catch up.
Ah.
She will come back soon, I think.
Yes.
Yes. Yeah, sure.
Well, I will occupy the time in between. This hackathon had the opportunity to gather experts from all the different fields. And because communication, even between experts, can be difficult sometimes if you come from technical experts, domain experts, and it's important to have some opportunities to have some hands-on initiative experiments to be able to communicate and align the understanding and the vocabularies. Bente, did you come back in between?
No, she's missing. So I would suggest that I will go further on to the next presentation. That will be me. And I will show how we can cover metadata standards and extensions in CKAN. The problem is that the normal metadata standards like Dublin Core, DCAT, GeoDCAT, and ISO are well defined, but some communities do not have enough metadata, so we have to make some extensions, and we will use the system fields from CKAN. So what I will explain in the next minutes. So here you see, can you hear me?
Yeah.
Okay, and you can see the slides too. So here we see the data flow in the data hub of NextGeos, which is realized here with the data hub from CKAN. And we are harvesting from data sources, mainly from the Copernicus and Sentinel missions satellite data, but there are also some others. And in the first step, we are harvesting metadata, put them into metadata catalog in CKAN, a database, and then you can search in this metadata catalog. Let's say if you want to see from March to August the pictures of Belgium to make a time series to observe the crop in a particular area. Then you can search it by hand here with a web GUI, or you can use Open Search API to connect the machine to search for the particular data you need for your work. If we have in NextGeos 10 pilots, which can use the data hub to search for their particular data and will, with the metadata, find their raw data or resources that they can download directly from the sources and take it as input data for their own applications. Normally, it's a numerical intensive computation. It might be a time series, it might be some machine learning, as we will hear, maybe. And then you generate some output, and this output can be provided to the end users outside of NextGeos, that may be in the civil society, government, business, or other research. But what we can do also is that we create from the output files metadata, which will be harvested in CKAN also, so that you can see in CKAN the input here from the original sources and the output here from the value-added data from the pilots. Next slide. Here you see, you must not learn it by heart now, normal schema for Dublin Core, the most prominent metadata standard. What we need here is some information. Who's a contributor? What will we show in this data? Date form we want to have. We want to have a format. What physical format do we have? We have an unambiguous identifier. We have maybe a language and so on. And somewhere we have an URL where we can download the data himself and create search by this metadata. But if you come to special excuse me, DCAT, GeoDCAT, and the ISO schemas look similar. Same kind of metadata for the geo folks. We must have geospatial data additional, and INSPIRE has it in the ISO metadata schemas. But this is not enough if you come to, for example, essential biodiversity variables to create or calculate some indicators of changes in biodiversity. You have a lot of variables from biology, which are not part of the metadata standard I discussed earlier. And then you have several phases of essential biodiversity variables data set, where you can have as output the data and the metadata. Here you see three phases. The task now and the challenge for us is to bring the normal standard community together with other communities of which need metadata. I said it here, essential community variables, because we have the same problem with climate, with ocean, and here with biodiversity. And now comes my part with the sledgehammer. What we will try to do is that we extend the normal metadata schemas with the community metadatas by using the custom fields in CKAN. And this is simply that you have an element and a value. Don't take too serious what he has written, but the schema is the same. You have always a variable and a value, which is put into a table. And then if we have defined the biodiversity variables, we can attribute then a normal metadata with the community values, so that when we harvest from the source, like a satellite data set, we can, while harvesting, attribute some essential biodiversity variables, so that we can store it together with metadata about the pictures from the satellite, maybe, or the other data sets from the satellite, and then we can search in the with web or with API search for the variables of the essential biodiversity values. So they will appear here in CKAN as tag or as searchable in the OpenSearch API. This would be a great success for the biodiversity community if the data are searchable by ECVs. And then the same can happen that they calculate numerical intensive things with their application in the cloud, and the output can be also be harvested by us together with the then essential biodiversity values which are connected to this output files we see there. So this is the thing we want to do, and we will have the first test in the area of Orléans or somewhat later, but we want to go this way and to have a better understanding for the need of the biodiversity community. I shall end my presentation here. So I'm off. Is Bente back again?
Not really.
Not enough.
So I think we will continue with Elnaz then.
Yeah.
Yes, I'm going to share my screen. Okay, I hope you can see my screen now.
It's coming up. Yeah, there it is. Yeah.
Okay. Okay, I'm just talking about the biodiversity pilot in NextGeo project. We and our colleagues from Wageningen University are involved in this task, and we try to reveal the value of the European Data Hub for the creation of the remote sensing essential biodiversity variables through making a connection between policy makers and users with the space agency. These users can be researchers, scientists, or, for example, insurance companies and decision makers. We have more partners in this subtask. DLR, German Space Agency, and also University of Barcelona are the other partners in biodiversity pilots. Sorry. Previously, my colleagues, Andreas Skidmore and his colleagues, proposed the few variables as important essential biodiversity variables in their papers published in Nature. For 5 EBV classes, we have different EBV classes consisting of species population, species traits, ecosystem function, and ecosystem structure and community composition. You can see some of the variables that they proposed as the most important essential biodiversity variables here in this hexagon. However, in the last year, I guess on September, University of Twente hosted a workshop, and we invited senior international scientists and also some colleagues from Space Agency to prioritize the EBVs. Initially, around 121 variable proposed as an essential biodiversity variable, and then during the workshop, some variables added or removed, and at the end, in total, 123 variables suggested to consider, only just consider. As you know, from different sources of the Earth observation, essential biodiversity variables can be created. In this task, we try to first identify the available remote sensing essential biodiversity variable, and later we try to retrieve these variables using high resolution data in the cloud. So let me check first one. So in this regard, we first identify the all available RS EBV products, but here we consider the resolution and also the scales. I should highlight this because next show try to create the European Geodata Hub. The scales is very important here for us. We mostly consider the data that can cover the Europe and also the globe and Europe. From our survey, we understood that most of the essential biodiversity products produced using 2 satellite MODIS and also SPOT. They are available and free of charge. People and users can download it. But among those variables that we consider as essential biodiversity variable, we choose leaf area index as one of the most important biophysical variable to first retrieve it through cloud computing and also use that as an input for cloud computing for European habitat models, which I guess Stephan will talk about it later. And the other EBVs can also, it's usable to use them as an input for European habitat models as well. Our study area in the next geos in our pilot consisting at the moment 2 study area. One of them is Netherlands and the other one is Bavarian Forest National Park in Germany. There are 2 study area that we are working on that to retrieve the some parameters consisting leaf area index to computing in our pilot. As I said, as a raw data, we just consider the high resolution data, which are available online. In this regard, we consider Sentinel-2 as our raw data, and then by using the TraDU platform, we first try to resampling and also atmospheric correction on this raw data. Sometimes you don't need to do atmospheric correction in some Sentinel-2 data, but in case that you need it, we added the algorithm in the cloud to do the atmospheric correction. Since the Sentinel-2 resolution Sentinel-2 data resolution is different bonds by bonds, we do the resampling in the cloud as well, and depends on which variable we are going to retrieve or predict. We will use different algorithm. We have different approach to retrieve these parameters. We can apply univariate techniques, multivariate techniques, or machine learning approaches to retrieve, for example, leaf area index. And at the end, we will have an output in map that the user can have them. We are thinking about where we have to store this output, because what we understood that CKAN doesn't have this capacity to store this output as a map, so we need another server. So at the end, we come back to the topic of Wolfgang. We just we had to follow this procedure. Recognize which data we want, and then do the modeling and drive or parameters. And at the end, we have an output in map, and after that, we have to create. We have to make a metadata. So we are still working on that. Which kind of metadata we have to use it in collaboration with the Wolfgang and the other partners. So till now, it's what we have done in biodiversity pilot. So I guess that's it.
Okay, now it's my turn, I guess.
Yeah.
Yes, sir.
So I'm going to share my screen. Okay, that's the PowerPoint. There you are. So I will talk about the implementation of the RS-EBVs in habitat modeling using a web client and cloud computing. which was quite a challenge, I must say, but we get great help of people from TerraDue. And so now we have already a client running and working, and we are quite happy with that. A few remarks before I go into the showing you the web client. I wanted to do a live demo, but I thought maybe this is not a good idea because demos always tend to fail. Murphy's Law. So I stick to a PDF. Okay, so just a few remarks. Okay, so we will demonstrate the use of the RSEBVs for the habitat monitoring because we want to support the EEA and also the ETCBD, those environmental agencies in Europe. And we hope by using RSEBVs in the habitat modeling that we can have better output and we can have better predictions for our valuable habitats. As input for the modeling, we use, first of all, observation data, so in situ data, ground truth data, which is derived from the EVA database, the European Vegetation Archive. And so we have data that has been assigned to about 200 UNIS habitats. So we have classified our plots into UNIS habitat types. UNIS stands for European Nature Information System. And within this UNIS, there is a habitat classification. I would say it's, let's say, a wall-to-wall classification of European vegetation. The model can be executed, so using a selection of a maximum of 30 predictors, including 7 climate parameters for the world CLIM data, 7 soil parameters, and about 13 RSEBVs. The EBVs that we got from IDC and Enschede, but also here in-house from my colleagues. And all the predictors at the European level have the same extent, and the resolution is 1 by 1 kilometer. And for the modeling, we use the MaxEnt software. So, but of course, 1 by 1 kilometer is not very, not a very high resolution. But so future versions of the web application will probably also operate on a smaller scale. For example, the Netherlands and the Bavarian Mountains. It was already mentioned by Elnaz, but hopefully then with higher resolution predictors. Yeah. So, and the modeling process is currently running on the TerraDue cloud platform and is driven by a VPS client. A VPS means web processing service. So I'm going to now show you the application. This is the opening screen of the application. So can you see my mouse?
Yes.
Oh, okay, cool. Because okay, on the left side we have 2 sections. We have one section with the UNIS habitat types, from which we will select a single habitat type, and then below we have the model predictors that will unfold. If I click on it, we will see that later. And here we have some general information about the application and what is this all about. Okay, next slide. So here if we click on UNIS habitat types, the classification will unfold. This is a classification, in this case, up to 3 levels. So, and on the 3rd level, we can select a UNIS type. In this case, I've selected a Fagus woodland on non-acid soil. Fagus is the beach, so we have beach forest on, let's say, calcareous soils. And when you select that type, you will have a fact sheet. So we have the short description of the UNIS type. And if you go further, we will also, if we select here on top, we have the menu. So we have a distribution map. So these are all the distribution points, all the in situ data that we can use for the modeling. And the next step. Now, the next step is that we select our model predictors. So as I mentioned, we have soil predictors, we have climate, and we have EBVs. And so you can select all of them if you like, but you can also select only a number of predictors that you want to play with. And once you have selected, you click on the calculate button and the calculation is done. So currently the calculation in the cloud is a slow process, and we need to optimize this so that hopefully we'll speed up. But for now, everything is working. A little bit slow at the moment, but it's working. So once we have done, we get results. And one of the results is a prediction map. So here, based on our in situ data and the selected predictors, we now have, let's say, a prediction maps. It's a kind of suitability map. So it will show you where this habitat type may occur in Europe. And second, what you also can see on in this section here, we see now some numbers, some percentage value and a bar, and that will indicate the contribution. So, for example, the digital elevation map, the DEM, has a contribution of 80% to the model. Okay, so on each predictor involved has a kind of contribution. So most of the predictors have a low contribution, but some of them are really important. In most cases, some of the climate variables are very important in predicting the distribution. That's quite obvious, of course. Then here we have another output. These are the graphs. So for each of the variable, we have two kind of graphs, and also the graph we call it the response curve. So that is the response of the predictor to the chosen observations. And then, okay, we have two other buttons here in the menu. We have the results, so we can, if we like, we can download the results. So you have all the output from the Maxent model is downloaded to your computer, including the maps and including all the graphs and so on. But there's another button, it's called CKAN, and this function behind the CKAN button is not yet implemented. But what we have in mind is that if the user finds this result so interesting that he wants to share it with other people, we would like to upload or let's say register this result in the CKAN so that anybody can see what has been done. But this last part, of course, we also need the user also needs to provide some metadata, of course, before it can be registered in the CKAN. But in this case, we can permanently make output of this model available for other people. So normally output is only kept for 2 days. There's also a button called recent calculation. So all calculation that you did in the last 2 days will be remembered, and you have a very quick access to these results. So that all is available right now if you would choose this URL, but we are still waiting to go in production. So TerraDo promised us to make everything available in production environment by the end of March. So hopefully that will be the case, and then everybody can start playing with this web client. That's what I wanted to say.
So Bente, can you hear us? So it seems a little bit that we have lost Bente.
I think she must have kind of technical problems.
Yes,
I see Bente. Okay, seems that today
Karel?
You are privileged, Karel.
Okay, today I have also some problem with connectivity. So I think that on the end, what I would like to say that I would like to see all from you in Orléans to meet there, to work with us. Of course, will be good to start preparation in advance, because Orléans will be main presentation. So please join, register for the hackathon, join our working group, and try to contribute and discuss with the people our experiment, because I think that this is the main way for us, and I hope that we will succeed and we will be able again to demonstrate some good progress in our hackathons and in Orléans, mainly with the metadata. So see you in Orléans.
Okay.
See
Bye-bye.
you.
Thank you.
Bye.
Okay.
Bye-bye.
Okay.
Bye.
Bye.